I'm back on Life with Miss H, and we're going to continue our quadratic notes. Last time we had looked at standard form and how to graph from standard form, find another point, find the vertex. This time, this video will be vertex form. Let's go. Started some. Okay, when working with vertex form of a quadratic, if you kind of look here, this will be your vertex form of the equation. Y equals a times x minus h squared plus k. And next, a, h, and k all affect the parent function y equals x squared. So that's going to stretch it. It's going to move it around, move it up and down, left and right, etc. If you look, I kind of broke that down for you all. A will stretch and compress it. So if the value of A is a positive whole number or higher, so like 1, 1.5, 3.5, or if it's a negative integer or higher, so like -5, -3.5, those will all stretch. Anything less than 1 or -1 but greater than 0 is going to compress it. Your H will move it horizontally, so that will move it left and right. K will move it vertically up and down. And then the X and Y in your equation comes from another point that falls on the graph of the parabola that you're graphing. Going back to your A, if A is a negative number, it will also reflect the parent function as well. If you look, you can find your vertex from the vertex form. Your vertex is, you would read that as the opposite of h, comma k. So the h in your equation will become your x value of your vertex. The k will be your y value of the vertex. So it's the opposite of h and just paired with your k. So I've got an example kind of already worked out. If you look at the equation, you got y equals 3 times x minus 4 squared plus 4. So your vertex would be 4, 4. So the opposite of a -4 is a +4, and then the +4 that's in your k spot just kind of tags along. If you wanted to break it down, if I was to ask you all to describe what happens, the 3 would stretch it by 3, so it would make it more of a narrow graph when you look at it. The -4 that's in the h's spot, even though it's negative, when you apply that where you're bringing it back to the opposite, it would actually move that to the right. And then the +4 on the outside, that's still going to be your constant. It's going to move it up. So I'm going to work an example with you all. I'm going to take the equation y equals 2 times x minus 5 squared plus 2. First thing that you need to do is find your vertex. So the vertex, you would take the opposite of -5. So it's going to be the opposite of this number. That's going to be your h. This right here is going to be your k. So my vertex is going to be at 5, 2. So I would come over to 5, come up to 2, and graph the vertex. If you notice, if I draw a nice vertical line down 5, that's still going to work as my axis of symmetry, as we talked about in the last video. That's going to cut your parabola in half. So when you fold it on that line, it should give you a reflection that should fold on top of each other. To find an additional point, if my line cuts through 5, then the easiest thing to do is choose either 4 or 6. It don't matter really which one you pick, where they're both 1 away, and this is going to be a reflection. Whatever value I get for 4 would also be the value at 6. So I'm going to go ahead and drop 4 in for x. So I want to replace the x value with 4. And then I'm going to start just solving order of operations. And where I don't have a whole lot of room, I'm going to kind of condense this. So 4 minus 5 would be a negative 1. Negative 1 squared is a positive 1. So you would have 2 times 1 plus 2. 2 times 1 is 2. Plus 2 would equal 4. So the point that I would pull off, I let x be 4, and my y is also 4. So I had the point 4, 4. So I would come from my origin over to 4, up to 4, draw a point. That gives me this curve shape. And then where it's a reflection, 6 is also 1 away from 5, so it's going to be at 4 as well. And then you have graphed your quadratic, your parabola. Thanks for watching. Give this video a thumbs up. Don't forget to subscribe.